Hi everyone, good morning. I am Sohom and I am here to present the paper using transformer based ensemble learning to classify scientific articles, co-authored by my colleague Ankush and me. Many a time, research papers get wrongly assigned to reviewers. Thus, an automated system capable of identifying domain of a scientific article is necessary. Our motivation is to develop such a system which is capable of classifying the abstract of an article into 7 predefined domains or classes listed here. This dataset was provided by the HDPRA team. It has a total of 35,000 instances, out of which 48% constitute the training set, 32% constitute the validation set, and remaining 20% is the test set. If we go by count of individual categories, we see yellow category has the least number of samples and CL category has the most number of samples. At first, I would like to highlight our contributions. It's mainly twofold. We have built a classifier capable of identifying domain of a scientific article from its abstracts, which performs better than one of the state of the art algorithm, which is a Skybert. Secondly, we have open sourced this model and it's available on GitHub. Here are the list of preprocessing steps and feature engineering steps which we have done. For model 1, which is a simple Roberta model, we didn't do any kind of preprocessing. For model 2, which is a combination of Roberta and LDA, that is topic models, we have converted the abstracts to lowercase, removed the stop words and performed lemmatization. For the third model, we have removed new line characters, extracted sentences, and trained a Roberta model with those sentences having 10 or more words. Now a question may arise, how did we come to this figure 10? This will be discussed in the later slides. The fourth model is a simple logistic regression based model trained over TF-IDF based features extracted from abstracts with n-grams ranging from 1 to 4. So all the models which I just discussed in the previous slide, they have been ensembled together using majority voting, and these diagrams depicts the overall architecture. Now I would like to discuss the list of experiments we did to arrive at the final model. Firstly, we started with zero shot learning, moved on to BERT, followed by Roberta and T5. Roberta gave best performances among all of these models which I just said. We also tried logistic regression over TF-IDF and topic models. Since Roberta has a limitation of 512 tokens as input, we performed sentence tokenization. We had built 4 models, first 3 by not considering sentences that had less than 1, 6 and 10 words, and the fourth one by taking all the sentences. We found that the model where we had taken sentences with more than 10 words did better than all other models. Finally, we benchmarked our model with Skybert, which is one of the state of the art models when we discuss about scientific literature. Now I want to share with you our results and discuss them. Firstly, number of submissions were restricted to 3. So the test column which you see at the extreme end, it has only 3 entries and rest as blank. From this table, it is clear that generic models like zero-shot learning do not perform well in domain-specific tasks. Fine-tuning is essential. Model 4, which you can see, is a TF-IDF plus logistic regression model. It takes least amount to train. The ensemble of all four models, 1, 2, 3, and 4 models, which I just discussed in a couple of slides ago, performs best for a training, validation as well as test set. As mentioned earlier, it performed better than Skybird, one of the state of the art algorithms, for both training and validation set. Each of the models performed best for the class CL, which is computation and language, and worst for the class DC, which is distributed computing. Here I would like to reveal the work which we are going to do in future. We would first like to replace the Roberta based embeddings with Skybird in the overall model architecture discussed previously, and check if that improves the overall performance of the model. Secondly, would like to replace the ensembling technique, that is majority voting method, by a meta classifier or a fully connected layer. Thirdly, the model at its present is huge in size. We try to reduce the model size. Here is the list of research papers we had referred to. Any questions? Thank you everyone. You have been a great audience. Special thanks to the SGPRA team for having me here. Thanks again. Have a nice day.